What's happening, dogs? Mr. Allen here with a fun little application of combinations here. We got how many different color combos can you write with if you have 12 different colors and markers and you pick 5 to write with each day. Perfect scenario for a teacher here. I love having a fat stack of markers to choose from, and I happen to have 5 right here in front of me. So let's say I picked these 5 colors out of my stack of a dozen markers that I had to write with, all right, and that's my day 1 choice. These 5 markers. I got yellow, blue, orange, green, and pink. Okay. Now, let's say day 2. Is that a new combination? Is that going to look different on the board? No, it's not going to look different on the board. I'm still working with the same 5 markers. And that's what we mean when we say, does order matter or does order not matter? But I find that wording kind of confusing because it's like, well, I'm still thinking about the order, right? What do you mean by that? Well, here's what we mean. Does it give you a new result, if you will? No, I'm going to have the same result. I'm writing with the same colors on the board. When order matters, okay, or we're taking into account in our calculations, think about it more of like a sports team or maybe like a class club. Like, let's just say we got a club, we got a president, vice president, treasurer, secretary, and a hype man. Okay, a hype man is in there as well for this club. You got to have one. Okay, well, if I chose, like, say Adam was president and Becca was vice president, so on and so forth, and assigned 5 people to these things. But then one day said, you know what? We're actually going to have Becca is going to be president and Adam is going to be vice president, and the same other people are doing their jobs. That's a new situation, right? That's completely different because I've swapped the vice president and president role. That's called a permutation, something totally different, but that's where the order, the way in which I arrange these things would actually matter. But with colors, no. Okay, it's just combination here. So I could, say this is combination 1, then take a color out. Now I got purple in here, right? That's a new one. And then maybe I take that out and then I got red in here this time, right? Take that out. Now I got white in here and write them all down, tally them up. That's going to take forever. Perhaps there's a better way. There is. I'm going to help you out, okay? So let's write some things down. This is what's called a combination, okay? Where we'd say that we have N, C, R. N choose R. We have N elements to choose from. We're going to pick 5 of them out in this case. We got 12 that we're picking from. We're going to choose 5 each time, okay? So they can also be written like this with like a really tall set of parentheses. That's fun. But it has a little formula. It is N factorial over R factorial times N minus R factorial. So in our particular situation, we have 12 choose 5. So in my formula here, I'm going to have 12 factorial over R factorial, which is 5, and then 12 minus 5 factorial. You might be wondering right now, depending on where you're at in this stuff, what is factorial, bro? Factorial is you're going to take the 12, multiply it by 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Everything after it. Every integer after it, okay? So we're good there. We got 12 factorial. I'm going to clean this up, though. We got 5 factorial, and then we have 7 factorial. Now, you can actually do some of this stuff by hand. The numbers might get a little large. We'll bring the calculator into this in a sec, but there are ways of simplifying these things. I like doing like this. I know that 12, I don't know why I'm using all these different colors. 12 factorial is 12 times 11 times 10. All those, right? And then 5 would be 5, 4, 3, 2, 1. And then 7. Okay. It's a lot of numbers. But I can start canceling things. And maybe you'd be like, why do you even write them out? I already see it, man. This right here can just cancel out with the 7, 6, 5, 4, 3, 2, 1 right there. Nice. Let's see here. I see a 2 and a 5. That's 10. Boom. Numerator, denominator, gone. All right. I see a 4 and a 3. That gives me 12. Dang, I just cut out so much stuff right here, and now I'm just left with, it looks like 11, 9, and 8. So let's just go ahead and multiply that all in here in our calculator. 11 times 9 times 8, and then we just have 1 left in the denominator, so we get 792. Oh my goodness. So you're telling me that there are 792 different ways that I can choose 5 colors from a stack of a dozen. That's like a lot of school years, man. A school year is 182 days. That means that I can go over 4 school years of picking different color It doesn't seem right, but it is. I swear. It is. So 792 combos. It's kind of cool, man. There are other ways of doing this, okay? In your calculator, I got you, okay? In your calculator, if you hit math, okay, and you arrow over to probability, your third option is NCR. I'm going to hit enter on that. We can type in 12, arrow over, I type in 5, hit enter, boom, I get 792. Now, some of these, they don't work, they don't look quite as nice and like with the small subscripts and stuff. It might look like this. Check it out. I'm going to go into classic mode right now. You don't need to do this, but if your calculator looks a little different, when you hit this, go over to probability, NCR, notice how it comes up a little bit different. I actually need to type, I find it best to type the number first, 12, math, arrow over to probability, NCR, 5. I still get the same answer, just typed in, looks a little bit different, right? I'm going to go back to the math print mode. I find that best, right? One other thing, too, we can actually type all this stuff in if you wanted, right? I can hit alpha x for a fraction or alpha y equals for a fraction. I'll do 12, hit math, arrow over to probability. We got the factorial right there for option 4. Down here, I got 5, math. It takes a little longer to do this, but whatever. Maybe you just have to deal with some factorials and it's not a combination, right? So it helps to know where the factorials are. And then we got 7, so math, arrow to probability, boom, wonderful, hit enter, I still get 792. So again here, guys, 792 different combinations. That's insane, right? You'd have to write all those up, count them up. I mean, it'd take forever, man. But there we go. You can do it in the TI. You can write it all out. Hope that helps, guys. Get you a little bit of understanding of combinations, what it's meant to be a combination, why we say like the order doesn't matter here because it doesn't make a different result, if you will. I'd still be writing with the same 5 markers no matter how I arrange those markers. All right? Cool? Awesome. Hope this helps, guys. If you have any questions, pop them in the comments, like it, subscribe it, do awesome math things, and keep watching dope math vids. See you later.